Welcome to the final part of our business analytics series. Myself, Gokul. I'm working as an assistant professor in the Department of MBA, Sri Muthukumaran Institute of Technology. This is part 4 of Unit 5, Prescriptive Analytics and Optimization. Today, we will explore advanced predictive analysis techniques, specifically stepwise multiple regression, and then wrap up the entire course. In this final session, we will cover analysis of predictive analytics, a review of what predictive analytics accomplishes, multiple regression, stepwise methods, backward versus forward stepwise regression. Let's begin with a recap of predictive analytics. Before diving into stepwise regression, let's review what predictive analytics accomplishes. Predictive analytics is the application of advanced statistical methods, information software, operation, and research methods. These are used to identify predictive variables and build predictive models to identify trends and relationships not readily observed in descriptive analysis. Key insights: knowing that relationship exists explains why one set of independent variables influence dependent variable like business performance. Example: knowing that customer age, income, and browsing history independent variables influence purchase likelihood. Dependent variable allow us to build a model that predict future purchases. Then multiple regression. When building multiple regression models, one important question is which independent variable should we include? The procedure for answering this is called stepwise multiple regression. The challenge with many potential predictor variables, including all of them, may lead to overfitting, model fits, noise, not signal. Then multicollinearity. Variables are correlated with each other, reduced interpretability. Stepwise regression automates the process of selecting the best subset of predictors. Then backward stepwise regression starts with all independent variable placed in the model. The process start with full model, all predictors included. Evaluate which variable contributes least to the model, the worst predictor. Remove the variable, re-evaluate the reduced model. Repeat steps 2 to 4 until only statistically significant variables remain. Analogy: think of packing a suitcase. You start with everything you might need, then remove items one by one until only the essential remain and the suitcase is still functional. Result: a statistically significant model with only the most important predictors. Forward stepwise regression start with best related variables. First, using correlation analysis as a guide, the process is identify the single variable most correlated with the dependent variable, add the variable to the model. Among remaining variable, find the one that improves the model the most. Add the variable, repeat steps 3 to 4 until adding more variables no longer significantly improves accuracy. Think of building a team. You start with the best player, then add the next best who complements the team, and continue until adding more players doesn't make the team better. A parsimonious, simple but effective model with only the most valuable predictors. How do you choose between backward and forward stepwise regression? Backward selection advantages considering all variable initially useful when you have many potential predictors to be allows variable to be potential and based on their contribution in the full context, which will be removed. Forward selection advantages are computationally faster with very large number of predictors, build more sequentially good when you have clear idea of the most important variable. Common practices. Many analysts use both and compare results. Some use stepwise, a combination of forward and backward, where variables can be added and removed at each step. Stepwise methods have been criticized for overfitting and instability. They should be validated on the separate data. Before we end, here are my final takeaways. Analytics is a journey, not a destination. Start with the descriptive, then build toward predictive and prescriptive. Second, data quality matters more than algorithm choice. Garbage in, garbage out. Business context is everything. The best model is useless. The best model, the best model is useless if it doesn't solve a real business problem. Visualization tells the story. Don't just show numbers, show insights. Prescriptive analytics is the ultimate goal. Telling decision makers what to do creates the most value. Then what's next? Practice with real data sets. Learn tools like RStudio, Python, or SQL. Take advanced course in machine learning. Apply these concepts in your job or projects. Thank you for being part of this learning journey. I wish you all the best in your analytics careers. That concludes the part 4 of Unit 5 and the entire business analytics course. I hope you found this series valuable and engaging. If you enjoyed this lecture, please like, share, and subscribe. Reach out with questions in the comment. Thank you for learning with me. Stay curious, stay data driven, and I will see you in the future courses. Goodbye and all the best. Thank you.